Okay, we have introduced the two-port network. And the last time, the two-port network. At first, we have introduced the difference between the two-port network and the one-port network. And then we discussed the equation and parameter of the two-port network. We have discussed the Y parameter, Z parameter, T parameter, H parameter. We discussed the one-port and two-port network difference, and discuss the two-port network and four-port network difference. And then we discuss the parameters of the two-port network. There are total 6 parameters for two-port network: Y, Z, T sharp, H sharp. But we discuss only 4. We discuss the Y, Z, T, and H, because the T sharp is the inverse of T. H sharp is the inverse of the H. The T means transmission. The H means hybrid. Today we will discuss the equal circuit for two-port network. For the equal circuit for the one-port network, we have learned this in the undergraduate course. The equal circuit, we have 2 types: the Thevenin circuit and the Norton's circuit. This is the equal circuit for the one-port network. Today we discuss the equal circuit for the two-port network. Any linear two-port network can be substituted by a simple two-port network. And pay attention, the equation, the network should have the same voltage and current equation. This means the same parameter, 6 parameters, the same 6 parameters. Different parameter will cause different equal circuit. The equal circuit used to make analyzing simple. This is the aim of the equal circuit. At first, if we use Z parameter to express a circuit, U1, U2, use I1, I2 to express this Z parameter. From this parameter, we can get the equal circuit very easily, directly. For this Z11, we can treat it as a impedance. For this Z12, I2, we can treat it as a dependent source. So the U1 is this impedance voltage I1 Z11 plus this dependent source voltage Z12 I2, and the U2 Z21 I1 is this dependent source, and Z22 I2 is this impedance. So in this circuit, U2 is Z22 I2 plus Z21 I1. So this is the most simple equal circuit. And get this circuit from the function directly. And pay attention, in this circuit we can find this point, connect to this point directly. That means they connect inside. Pay attention, the original circuit, for this circuit, maybe this point we use 1 sharp, this is 2 sharp, this is 2, 1. The 1 sharp and the 2 sharp may they have not connected together, but in the equal circuit they have been connected. This will not affect this function group. Method 2. Z11 I1 plus Z12 I2. We will minus a Z12 I1 at first, and then plus Z12 I1. Minus this part and plus this part. For the U2, Z21I1 plus Z22I2, Z21I1, we plus this part at first, and then minus this part, Z12I2, and minus Z12I1. From these two groups, these two function groups, U1, I1 multiple Z11 minus Z12 is this part. For the second part, we use this Z12 to express this I1, this I2, so this part is I1 plus I2, I1 plus I2. So the second part means this impedance voltage. The first part, Z11 minus Z12, means this part voltage. For the U2, Z12 I1 plus I2 is this part. Z22 minus Z12 I2 is this part. Z21 minus Z12 I1 is this dependent source. So this is another equal cycle of the two-pole network. And if the network is reciprocal means the symmetry, the matrix is symmetry. Z12, Z21 are equal. If they are equal, this will be 0. So the network will be a T network. This is T network. If we use the Y parameter to express, use voltage to express current. Method 1, U1, I1 is Y11 U1, this current, plus Y12 U2, this dependent source. I2 is Y21 U1, this dependent source, plus Y22 U2, this current. This is method 1. For the method 2, Y11 U1 plus Y12 U2, we plus Y12 U1 at first, and then minus Y12 U1. For the I2, we will minus this part at first, and then plus the Y12 U2, and minus Y12 U1. Then from the first function, Y11 plus Y12 U1 is this part current, and the minus Y12 U1 will be this impedance current, this part. For the I2, I2 is here, I2 is minus Y12 U2 minus U1. This part means this current. Y22 plus Y12 U2 means this current. This part means the dependent source. So this is U2 expression. And if the network is reciprocal, that means this part is 0. So the cycle will change to be a pi cycle. This pi cycle is also a delta cycle. And the T cycle is also the Y cycle. T cycle is also Y cycle. The pi cycle is also the delta cycle. This is delta cycle. Pay attention, reciprocal cycle will be delta cycle. The reciprocal cycle can also be expressed by the T cycle or the Y cycle. Pay attention, the equal only for the port voltage and the port current. not equal for the inside of the port. The inside of the port, pay attention, this point and this point in the equal circuit, they are connected together. That means these two terminals have the same voltage, but in the original circuit, maybe they are not connected together. So the voltage or the potential are not the same. So the equal only means U1, I1, U2, I2 equal, but not means this terminal and this terminal equal. The equal circuit is not uniform. We have introduced the T equal circuit, pi equal circuit. If the network is symmetry, the equal circuit will be symmetry also. The network or the matrix is symmetry. So the equal circuit will be symmetry also. The pi circuit can change to T circuit from T to pi or from the delta to y. According to the relation between the y and z and the other parameter, we can get other parameter equal circuit easily. This means if we give you the T parameter, transmission parameter, or the hybrid parameter, we can change the T and H to Y or to Z, and then draw the equal circuit. So this part expresses the equal circuit of the two-port network. The equal circuit is not uniform, has many different equal circuits. Now we discuss the interconnection of network. That means we connect several different two-port networks. Any complicated network can be decomposed to some simple two-port networks. We can analyze the simple networks. Then we use interconnection rule of networks. The first kind of interconnection, we call it as a cascade. The two-port network P1 and P2, we connect the output of P1 to the input of the P2 directly. We call this cascade. This is not serial, pay attention. This is not serial connect, not serial. We call this cascade. We will introduce serial later. This is not serial, pay attention. This is not serial connect. This is cascade. For the cascade, we use the T parameter to express. T parameter. The total network. This is total network. We use T to express. Use T1 express P1. Use T2 to express P2. This is T sharp. T sharp 2 is P. This is P1. This is P2. This is P1 expression. Use the T sharp. This is P2 expression. Use the T sharp 2. The cascade U1 I1 U1 sharp I1 sharp. Pay attention, what does this mean? This U1 sharp I1 sharp is here. This is U1 sharp I1 sharp. U1 I1 is here. So they are equal. So this function means these are equal. Function 2 U2 sharp I2 sharp minus equal to the U1 sharp 2 I1 sharp 2 means this voltage equal to this voltage. This current inverse equal to this current. The I1 sharp 2 equal to the I2 sharp minus. This function U2 sharp 2 minus I2 sharp 2 equal to U2 minus I2 means this part, the output. This U2 sharp 2 equal to this U2, I2 equal to this I2 sharp 2. So U1, I1, U1, I1, U2, I2 sharp. We use T1 to express this T1, T sharp. And the U2 sharp, I2 sharp minus, use this part to express. This is T sharp 2, this is T sharp. So when the circuit cascaded, the total T parameter will be the T1, because this T1, this T2, multiplied together. The total T parameter when cascaded will be the T1 and T2 multiple. The matrix multiple. Conclusion: when cascade a network, the T parameter will equal to the multiple of the original network's T parameter. And pay attention, when cascade T parameter is a multiple of the matrix. Matrix, not the multiple of every component. When cascaded, the port rule will never break. What does this mean? The port rule will never break. The port rule means this I1 flow in will flow out. This I1 flow in, flow out. This I2 flow in and flow out. When cascaded, this I1 flow in, flow out. So this I2 will equal to this current also, and this current flow in, flow out. This flow in, flow out. So the port rule will never break. If they are equal, these two must be equal because they should conform to the KCL. If this equal, this two current equal, this two current will be equal. Then this will be equal. So when cascaded, the port rule never break. For example, find the T parameter of this Y connection circuit. We can treat these three components as three different two-port networks and cascade. Treat them cascade. This is network 1, network 2, network 3. So the total T parameter will be T1 multiple T2 multiple T3 For the T1, for this sector, the T1. For the T1, pay attention how to write the T parameter. Everybody should be able to write the Z1T. For this T1, how to write the T1? I will tell you how to write the T1. For this T1, for this form, I will give you the details. This I1, this I2, this U2. I1, I2, U1, U2. We want to write the T parameter. The T parameter is U1, I1 equal to A, B, C, D, U2 minus I2. We should find the A, B, C, D. Find A, B, C, D. The first, we assume I2 equal to 0. That means the open circuit. Open the right side and connect a source to the left side. Open. So this will be U2. This will be I1. and this will be U1. So in this sequence, U2 will equal to the U1 equal to U2. The I1 will be 0. So the A position will be 1. And this position, C position, will be 0. This is U1, this is I1 equal to U2 minus I2. So we found the AC at first, and then assume U2 is 0. U2 is 0 means should connect. And this current will be minus I2. So the I1 will equal to minus I2. That means this position will be 1. I1 equal to minus I2. And the U1 will equal to this 4 ohm, 4 mod minus I2. So this position will be 4. So this is how we write the T1. 1401. Pay attention, everybody should know how to write the T1. How it comes from 1201. And for the 6 ohm, so it will be 1601. And for this circuit, we use the same method. We can write the T parameter. This is T2. Pay attention, everybody. You should write this T2 yourself. I have teach you how to write the T1 and T3. I have teach you. You should write the T2 yourself. This is important for you. The parallel connection. What means parallel? The parallel means the port 1 of the P1 and the port 1 of P2 parallel connected. Parallel means the same voltage. This voltage equal to this voltage. This voltage equal to this voltage. The port 2 of the P1 and P2 parallel. This is a parallel connection. We can use the Y parameter to express. For the P1, use the U1, U2 express the I1, I2 sharp. This Y1. For the network P2, we use the this voltage U1 sharp 2, U2 sharp 2 to express I1 sharp 2, I2 sharp 2. So this is Y2. This function expresses P2. This function expresses P1. The total current I1. Will be these two currents add together. This current add this current. That means add these two functions together. When parallel connect, this U1 equal to this U1, this U2 equal to this U2. But the total current will be the sum of the P1 current and the P2 current. So the parallel means when parallel connect, the total current, this total voltage, this is total Y parameter. So the total Y parameter will be the sum of the original Y parameter. So parallel connect the two-port network, the Y parameter will equal to the sum of original Y parameter. Pay attention, the parallel. Two-port network parallel. We use Y1 plus Y2 is classic. This parallel, and this parallel connect out. Sorry, too bad. I'm sorry. This is Y1, this is Y2. The total Y equal to Y1 plus Y2. This is two-port network parallel. Actually, we have named the one-port network parallel before. This is one port. Y1, Y2. This is one port parallel. This is the common parallel we have learned before in the undergraduate course. So this will also be Y1 plus Y2. This is one port parallel. This is two port parallel. They are similar. So why we call this parallel? This parallel is a common, pay attention, the common parallel we have learned before. Pay attention, if inside is a resist. It's just a common parallel we have learned before. Common parallel. This is Y1. This is Y2. So this one port parallel, this two port parallel. This is a difference between them. Pay attention. When parallel connect, it may violate the port rules. So the equation will be blocked. For example, this is a two-port network. This is also a two-port network. Now we parallel connect them. We will find this is 10 watts. This is 10 ohm, so this will be 1 ampere. This is 5 watts, so this will be 5 watts and 5 ohm. So this is 1 ampere also. So this will be 2 ampere. This will be 2 ampere also because 5 at here. It's 5 at here. This will be 2 ampere. This is 1. This is 2. So this will be 1 ampere. This will be 0 because this point short connect with this point. So it will be 0. This will be 2 ampere because this terminal short connect, but this terminal 10, this 5 connect together by the 2.1, 2.5 ohm. So this will be 2 ampere. This is 2 ampere. This is 2 ampere. This will be 4. So this will be 4 also, but this is 0. This 2 ampere. This is 1 ampere. So this will be 1 ampere. And this will be 1 ampere also. This is 0. So this will be 4. This will be 1 ampere. Now we check this part. We can find this 2 ampere flow in, 4 ampere flow out, not equal. This 1 ampere flow in, this also 1 ampere flow in. So they are not two-port network. And for this part, 2 flow in, 0 flow out, not equal. 2 flow out, 0 flow in, not equal. So in this part, not two-port network, also not two-port network. So the parallel connect violate the port rules. So the total Y not equal to the Y1 plus Y2. Because in this connection, the Y1 and Y2 never exist. Y1, Y2 only exist for the two-port network, but when them connect together, they are not two-port network anymore. But if the two-port network have common port, When parallel connect, it will not break the port rules. For example, the P1 has a common point. P2 also has a common point. If we parallel connect, this parallel connect, this parallel connect. In this part, it will not break the rules, because this should connect. So who should then parallel connect? This I1 sharp. So this will be I1 plus I1 sharp. I1 sharp 2. So this will be I1 sharp plus I1 sharp 2. This should connect. This also should connect. So the current will be randomly. So we can treat this will be I1 sharp, and this will be I1 sharp 2. Because the should connect wire parallel, we can think the current is random. It can be any value. Pay attention for this circuit. We can treat it as this network. The inside have a common point, and parallel with the 4 ohm is 4 ohm network. It also have a common point. Also have a common point. So in this case, they will not break the port rules. The serial connect. Pay attention, we have told this connection is not serial. This cascade connection. So what kind of connection is serial connect? This is serial. Serial means the same current. So this I1 flow in, will flow out, and flow in, flow out again. The same current. This I2 flow in, flow out, flow in, flow out again. So this is a serial connect. Serial connect will have the same current. When serial connect, we use Z parameter to express. Use Z parameter. Z1, Z sharp 2. Use this I1 to express this U1 sharp. Use this I1 to express the U1 sharp 2. When serial connect, the current, this current, will equal to this current. Equal. And the voltage, the total voltage will be the sum together. The current is the same. The voltage will be the sum together. So the total voltage will be the the P1 and P2 voltage are together. Use current express the voltage. These two currents are the same. So we will get the result is the impedance are together. So when serial connect, the total impedance is the impedance of the 2-port network are together. Make a conclusion. The 2-port network serial connect. This is Z1, this is Z2. The total Z equal to Z1 plus Z2. This 2-port network serial. Of course, we have named the 1-port network serial before. one port network. The 0 is add them together. So the Z equal to Z1 plus Z2 also. So this is 0. For example, this is Z1, this is Z2. So this 0 connect for the one port network, 0 connect. So they are very similar. One port network 0 and two port network 0 connect. They are very similar. We have discussed the one port parallel, two port parallel, and one port 0, two port 0. And when 0 connect, the Z parameter is equal to the sum of the Z parameter original equal set. 0 connect may violate the port rules also. So this equation will be blocked. For example, this is 2 ampere, this is 1 ampere. So 2 flow in, 1 flow in. So this will be 3 ampere, 3 ampere. This will be 3. This is 1 ohm, this is 1 ohm also. So this will be 1.5, 1.5. They will be equal. Now we can find for this network, the 2 flow in, but 1.5 flow out. 1 flow in, 1.5 flow out. So they are not equal, So this case, violate the port rules. So in this case, the total Z not equal to the Z1 plus Z2. Because Z1, Z2 never exist anymore. Because it's not a two-port network. It's a common four-terminal network. If the two-port network have common port, when 0 connect common point, it will not break the port rules. This is a special condition. P1 has a common point. P2 has a common point also. So this I1 flow in. This will flow out. This I2 flow in, flow out. So this point is I1 plus I2. This point is I1 plus I2. Because they are common point, the short connect cable, so we can treat this as I1, this I2. It can be random, it can be any current. So we treat them as I1, this as I2. So they're still two-port network. For example, for this circuit, we can treat as this two-port network. Have a common point with this 1 ohm, 0 connect. So for this circuit, the Z will equal to Z1 plus Z2. Z1 plus Z2. Okay, we have finished this part. We have finished. Okay, conclusion of this part. In this part, we discuss two-port. In this chapter, we have learned the two-port network. At first, we discuss what is one port and what's two port and what's a four terminal. Especially for the two port and the four terminal, the difference between them. This is the first question. The question 2 is the parameter. Parameters of two-port network. We have learned the Z and Y parameter is used to express U1, U2, I1, I2. If I1, I2 is plus U1, U2, this is Z. If U1, U2 is plus I1, I2, this is Y parameter. And we learn the T parameter, U1, I1 U2 minus I2. This will be T parameter. If you use U1 I1 express U2 I2 minus will be T sharp, T sharp. And we discuss U1 I2 I1 U2. This will be H parameter, and this will be H sharp, A sharp. So we have then total 6 parameters. 6 parameters. But we discuss G, Y, T, H. We discuss 4. We discuss 4. For all of you, you should know how to write the G, Y, T, H. So this is question 2. For the question 3. Question 3. What's the reciprocal and what's the symmetry? Symmetry. For the reciprocal, the G and the Y, there will be symmetry. The matrix will be symmetry. If the circle symmetry, this will be equal, and the diagonal will be equal also. Just symmetry, circle. This is a condition for the G and the Y. For the condition of the H and T, we can get the condition from G and Y. This is question 3. For the question 4, the equal circuit. The equal circuit, we have used G and Y to express. Use Y to G express the T circuit. The Y express the pi circuit. And the question 5. We have discussed the connection. The first kind of connection, cascade with T2 express T equal to T1 multiplied T2. For the second, we have learned parallel. One parallel connect is Y parameter express Y1 plus Y2. The serial connect, we use Z to express is Z1 plus Z2. For the T, the cascade, the port rules will never break. But for this parallel and serial, sometimes the port rule will be blocked. For this parallel and serial, sometimes will be blocked. So if the port rule be blocked, these two functions not exist anymore. Okay, this is the total of this chapter. Let's have a rest for 10 minutes.